Hello and welcome back to another video demonstration for pre-calculus classes with Mr. Lane. And on this video, we are going to demonstrate the completing the square process, except this time we're going to work with equations instead of expressions. So again, geometrically, here we have x squared plus 2bx. And just a quick recap of it, the area of the blue square is x squared, that's the first term. The combined area of the red rectangles is the second term, 2bx. And the area of the purple square ends up being b squared. And this is what we're trying to add in order to complete the square. Now, because we're going into the factoring when we go to solve, we're going to want to pay attention to the dimensions of the new square that we formed when we complete this square with the purple area added in. And originally, the dimensions were x of the blue square, but when you tack on the red rectangles and the purple square, the dimensions change their values from x to x plus b in both directions. And this is something that we are going to use when we go to solve. So this is just a quick recap of the basic idea for completing the square, but we're going to use it in order to solve equations. So our first demonstration asks us to complete the square on x squared minus 6x equals 0. Again, we follow our steps. First step is to make sure the coefficient of x squared is 1, which it is. Then we can divide the coefficient of x, negative 6, by 2 and get negative 3. And then we're going to square the results of the previous step to get the area of that missing corner. Take negative 3 squared. We put parentheses around it. So we have negative 3 times negative 3. Remember, this is the area of a missing corner, so that result should always be a positive value. And negative 3 times negative 3 is 9. At this point, we're solving an equation. And the most popular approach is to use the addition property of equality and add the result of step 3 to both sides of the equation. So we computed the area of the missing square to be 9. So we're going to add 9 to the left side, and we're going to add 9 to the right side of my equation. When I do this, I form a perfect square, trinomial. So I know that x squared minus 6x plus 9 can be factored down. And this is equal to 9 because 0 plus 9 is 9. And that leads us to x minus 3, all of that squared, equal to 9. So at this point, I have something squared equal to a number. So I take the square root of both sides. And remember, if you have to physically write the square root symbol, you got to put plus or minus with it so that you can take care of both the positive and negative cases that result from the square root of a squared quantity. You remember way back in algebra, the square root of a squared quantity results in the absolute value of the input, not just the input itself. So we're taking care of all of that extra steps by saying, look, if I have to physically write the square root symbol when I'm solving, we just put a plus or minus on one of the sides, and we go ahead and work with it from there. It's preferred to put it on the side that doesn't have the variable on it. So after I do this, I now have the equation x minus 3 equal to plus or minus 3, square root of minus 3. Solve this linear equation by simply adding 3 to both sides, and you end up with either 6 or 0 as the solutions to this equation. Our second demonstration asks us to solve the quadratic equation by completing the square. And this time we have negative 3x squared plus 5x is equal to negative 12. So again, we're going to follow our same steps. This time, though, we note the coefficient of x squared is not 1. So because we have an equation here, we're allowed to divide every term by that coefficient of x squared. So unlike the expressions where we had to factor it out, here we can kind of take a shortcut and go ahead and divide each term by the coefficient of x squared. So we do that, and we end up with x squared minus 5/3 x is equal to 4. Now we're back to our completing the square process. We divide the coefficient of x by 2, and the coefficient is 5/3. Divide this by 2, and we get 5/6. square that result and add it to both sides of the equation. So when we do that, we have x squared minus 5/3 x plus 5/6, all of that squared, plus, and that's equal to 4 plus 5/6, all of that squared. Again, remember, we're adding the area of that purple square to have a complete square, but we have an equation, we got to keep it balanced. So what you add to one side, you have to add to the other as well. So now the actual technique of completing the square is finished. We're now reducing ourselves to solving a quadratic equation. Remember that when you add that area of that purple square to both sides, the side with the incomplete quadratic on it automatically becomes a perfect square trinomial. So we can factor it down. And then we go ahead and combine the numbers on the other side, and we end up with the quantity x minus 5/6 squared is equal to 169/36. Again, we have something squared equal to a number. We go back to our square root solving procedures, taking the square root of both sides, add plus or minus on the side that doesn't have the x's on it, and simplify down. We end up with a nice linear equation in x. Add 5/6 to both sides. So we have 5/6 plus or minus 13/6. The denominators are the same. Go ahead and combine the numerators, and we get 18/6 or -8/6. And this can be reduced down to either x equal 3 or x equal -4/3 as your solution. So when you're using the completing the square technique to solve an equation, you still follow the same steps a little bit. You still make sure the coefficient of x squared is 1, but the difference here is that instead of factoring it out, if it's not, you can go ahead and divide it out because you have an equation, so you can do it to both sides. Just remember to do it to every single term, things separated by plus, minus, or equals when you solve these equations. We still proceed as normal. We take the coefficient of x after that, divide it by 2, square it. But when we had expressions, all we did was we had to do the add minus trick. When we have an equation, we can add it to both sides. So we add it to both sides, and that gives us a perfect square. And then we just reduce that down, take the square root. Don't forget your plus or minus when you take the square root. And now you're back to solving a linear equation. And this is just the arithmetic that it boils down to. Thank you for your time and attention.